Good morning, children.
Good morning, ma'am.
Good morning. Good morning, children.
Ma'am, happy Teachers Day, ma'am.
Thank you.
Happy Teachers Day, ma'am.
Thank you, children.
Happy Teachers Day, ma'am.
Thank you so much. Thank you.
Happy Teachers Day, ma'am.
Thank you. Thank you all, children. Thank you. So you all understood from the videos, you must have understood what we mean by congruent triangles. Is introduction to this chapter clear? The terms congruent figures, congruent triangles.
Yes, ma'am.
Yeah. So let's understand the SAS congruence criterion. See the statement. If two triangles, okay, so what are these congruence criteria? So we know that when two triangles are congruent to each other, it means they're identical. Two identical triangles, they are identical in every aspect. With respect to angles, with respect to sides. We know a triangle has 6 parts, right? 3 angles and 3 sides. So when two triangles are identical in every aspect, then the two triangles are said to be congruent to each other. Now, so what we understand is when two triangles are congruent, the three pairs of, so one triangle has 3 angles, another triangle 3 angles. So we have 3 pairs of angles. In the two triangles, we have 3 pairs. 1, 2, 3 pairs of angles. So these 3 pairs of angles must be equal. A triangle has 3 sides, another triangle, another 3 sides. So we have 3 pairs. So in two triangles, we have 3 pairs of angles and 3 pairs of sides. So when in two triangles, the 3 pairs of angles are equal and the 3 pairs of sides are also equal, then the triangles are congruent to each other. So now the question is, should we always check the equality of all these 6 pairs? Three pairs of angles, 3 pairs of sides. Okay, so when we have to show that two triangles are congruent, is it that we have to always show that all the 6 pairs are equal? The answer is no. You don't have to check when to show the two triangles are congruent. See, when two triangles are congruent, it means all these 6 pairs are equal. But to prove, if you have to show that two triangles are congruent, you need not check for the equality of all these 6 pairs. When you're given two triangles, see, physically, when you have to do it, you can just place them when you have, cutouts of two triangles and you have to check if they are congruent. Then you're just going to place them one over the other. Maybe you have to rotate one triangle, keep one triangle fixed, rotate the other triangle and try to place it in such a way that their sides and vertices coincide. So that way you can check if the triangles are congruent, identical or not. But when you have to, theoretically, when you have to write it down and prove that two triangles are congruent, not by actually checking the physical triangles, but if you have to prove two triangles are congruent, the question is, should we check or should we prove that all these 6 pairs are equal? The answer is no. You don't have to check for the equality of all these 6 pairs. That is the 3 pairs of angles and 3 pairs of sides. You don't have to check if all these 6 pairs are equal. So these congruence criteria, they reduce our job. They make our work easier. to prove that two triangles are congruent, we have these congruence criteria, which make our job easier. You just have to check for the equality of 3 pairs, not any 3 pairs. So we'll see what those 3 pairs are. So out of the 6 pairs of equalities which you need for congruent triangles, it is sufficient if you check for 3 pairs of equality, not any 3 pairs of equalities. We'll see what they should be. So this is what is given in the congruence criteria. Children, am I audible? Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay. So that's what is given in the congruence criteria. These rules tell us which 3 equalities must be checked in order to show that the triangles are congruent. So we have in all 5 congruence criteria. Criteria is the plural form of criterion. Criteria is the plural form of criterion. So when you say SAS, we say SAS congruence criterion, singular. But when you're talking about all the 5, we say congruence criteria, plural. We have 5 congruence criteria. SSS, congruence criterion. Let me show you that slide. Yeah, here it is. SAS criterion, congruence criterion, ASA, AAS, SSS, and RHS. So you can see three letters everywhere, SAS. So 2 pairs of equal sides and 1 pair of equal angles. 2 pairs. So in all 3 equalities, 1 pair of equal sides, another pair of equal sides, and the included angle is equal. 1 pair of equal angles, another pair of equal angles, and 1 pair of equal sides. ASA. 2 pairs of equal angles and 1 pair of equal side. AAS. So here, all the 3 sides. 3 pairs of equal sides. 1, 2, 3. So out of 6, it's sufficient if you check 3 of them like this. 3 equalities satisfying these, conditions. SSS, AAS, ASA, SAS, and RHS. RHS is right angle, hypotenuse, and side. So this criterion can be used only in 2 right triangles. When you have 2 right triangles and you have to show that they are congruent, or you will have to check if they are congruent to each other, then it's not that you can use only the RHS criterion. You may also use this depending on the information given to us. It's not that when you have 2 right triangles and you have to check if they are congruent, it's not that you have to use the RHS criterion. You can use the RHS criterion, or you may use any other criterion depending on the information given to us. But the thing is, RHS cannot be used in any 2 triangles. That is 2 triangles which are not right triangles. RHS is specific to right triangles. RHS is specific to right triangles. When we have 2 right triangles, then we may use this criterion to show that they are congruent to each other depending on the information given. RHS can be used only in 2 right triangles. It cannot be applied. So when you have 2, say, equilateral triangles, you cannot use the RHS rule and show that they are congruent to each other. R for right angle, H for hypotenuse, S for side. So these are the 5 congruence criteria. Let's see the proof for each one of them. My screen is visible, children. I'll keep asking you at regular intervals.
Yes, ma'am.
Screen is
Yes,
visible.
miss. It is visible.
Okay. All right. So this is the first one. So it's like as if, this was the first criterion which was found out. And the others are, developed based on this. The others are developed based on this criterion, SAS. So this is actually an axiom. It's sometimes called a theorem. It can be mostly called an axiom because the proof is mostly demonstrative. Like you can perform it. You can perform what is given as a proof can be performed or must be performed. So it is also referred to as an axiom. Axiom is a statement which does not need a proof, but in some textbooks you see it as a theorem. NCRT you will see SAS as an axiom. You don't have to really worry
Ma'am,
about
but
it.
actually SAS is an congruency only, no, ma'am.
Yeah, yes, SAS is a congruence criterion. Yes, the statement can be the statement for SAS is called a theorem, is also called an axiom. I meant the statement.
Okay.
Okay. So if two triangles have two sides, see here SAS, two sides include an angle. If two triangles have two sides, see here, two triangles ABC and DF have two sides AB, DE, AC, DF. Let's see what it is. Have two sides and the included angle of the one. So in triangle ABC, we say AB, AC, and the included angle A. 1 minute, children. Yeah, let me come again. So if two triangles ABC and DF have two sides and the included angle of the one. So this is one triangle ABC, two sides AB and AC, and the included angle. See, the sides AB and AC contain this angle A. AB, AC. Now it's like this. AB and AC can be regarded as the arms of angle A. That is the included angle. If the sides are the arms of an angle, then that is the included angle. If the sides are the arms of an angle, then that angle is included by the two sides. So these are the two sides of the triangle AB and AC. They are also the arms of angle A. That means angle A is the included angle for the sides AB and AC. So two sides and the included angle of the one, two sides and the included angle of the one equal to, if these are equal to the corresponding sides. So here AB corresponds to DE. AB is equal to DE is known to us. Corresponding sides, and then AC is equal to DF is known to us, is given to us. And the included angle. So see here, angle D, the arms of angle D are DE and DF. The arms of angle D are DE and DF. So that means angle D is the included angle, or is the angle included by the sides DE and DF. Why? Because DE and DF are the arms of angle D. That means D is the included angle for the sides DE and DF. So two sides and the included angle of one equal to the two sides and the included angle of the other, then this is enough. If you have this information, if you have these three pairs of equalities, then the triangles are congruent to each other. So now what you do? Imagine you have paper cutouts or cardboard cutouts of these two triangles. So you place them, you lift triangle ABC and you place it over DEF. All right, you lift this triangle ABC and place it over DEF in such a way that this vertex A falls on D. Because you know A is equal to D, right? You know that A is equal to D. So you place this triangle ABC over DEF so that A coincides with D. So since the angles are equal, angle A is equal to angle D, right? So when you place A over D, place this triangle over this triangle such that A coincides with D or A falls on D. And you turn it, you adjust so that AB falls on DE. You adjust it. You adjust triangle ABC and you place it over DF so that A coincides with D and AB falls along DE. Adjust it like that. Put this A over D and turn to whatever is needed so that AB falls along DE. But we know that AB is equal to DE. We know that AB is equal to DE. So that means definitely this point B will coincide with E. That means this vertex B will fall on vertex E. Because AB, this length AB is equal to this length DE. You have placed A on D. And you have adjusted so that AB falls along DE. Since AB is equal to DE, this vertex B will coincide with this vertex E. That is, B falls on E. This is what happens on this side. Happens with the sides AB and DE. Am I audible, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now let's see what happens on the other side. Now on the other side, that is with the sides AC and DF, this angle A is equal to angle D. That means this opening is the same. This opening. See, when there's an angle, there's a mouth, right? There's a mouth here. So now, since angle A is equal to angle D, since angle A is equal to angle D, this AC will automatically fall on DF because the measure here, the opening is the same here and here. A and D, this opening is the same. How wide here the mouth is the same for both because angle A is equal to angle D. So what happens on the other side is the side AC will fall along the side DF. It'll see once you've adjusted on this side, automatically this you don't have to adjust. You will see that AC falls along AF because this mouth, angle A is equal to the mouth here, angle D. So you don't have to adjust. You will see that AC falls along DF. But we know that AC is equal to DF. The length, not only is the angle equal, AC is also equal to DF. One thing is AC will coincide with DF. That is that AC will fall on DF, fall along DF. Not only that, since their lengths are the same, AC is equal to DF, you will see that C falls on F. C coincides with F. Again, here this side you don't have to adjust. It will fall. C will fall on F. You will see that C falls on F or C coincides with F because AC is equal to DF. So now on this side, B coincides with E. On this side, C coincides with F. So that means BC is equal to EF or BC will coincide with EF. Because B falls on E, B coincides with E, C coincides with F. Vertex C falls on vertex F. So that means BC will be equal to EF. That is, BC will coincide with EF. So now that means what has happened? A falls on D, B falls on E, C falls on F, BC is equal to EF. All the six pairs of equalities have been checked here. Triangle ABC covers triangle DEF exactly. Triangle ABC covers triangle DEF. You have placed this over this. Triangle ABC covers triangle DEF exactly, which means they're identical, which means they're congruent to each other. See here, all the six have been checked now. We had only 3 pairs of equalities, but all the 6 have been checked now. Because when you place this over this, we saw that B coincides with E and C coincides with F and BC is equal to EF. So the other pair of sides are also equal. BC is equal to EF. And if
Ma'am,
so,
but they haven't given that BC is equal to EF, no, ma'am.
no, when B falls on E and C falls on F, that means BC will be equal to EF. That's why they coincide.
Okay, ma'am.
So what is happening when B falls on E and C falls on F? BC is equal to EF. That means triangle ABC covers triangle DEF exactly, which means angle B will be equal to angle E, angle C will be equal to angle F. So the remaining pairs of equalities have also been checked. Angle B is equal to angle E, not given. But now, since this one covers this exactly, angle B is equal to angle E and angle C is equal to angle F. BC is equal to EF. The remaining pairs of angles and sides are also equal. So with these 3 pairs of equalities, we were able to show that the triangles are identical with only these 3 pairs of equalities.
Ma'am, I have a doubt, ma'am.
Let me just finish this, Shreyas. I'll get back to you. Definitely.
Okay, ma'am.
So with these 3 pairs of equalities, 2 pairs of equal sides and the included angles equal, we were able to show that triangle ABC coincides with triangle DEF and hence they are identical triangles, which means that they are congruent to each other. So this demonstrates that SAS is a valid congruence criterion. It's enough if 2 triangles exhibit this property, then the triangles are congruent to each other. Yes, Shreyas?
Ma'am, ma'am, in this, ma'am, we are proving that AB is parallel to DE and AC is parallel to DF and angle A is equal to angle D, ma'am. Totally, we are proving 3 statements only, no, ma'am. Why can't we prove that BC is parallel to EF in that statement, ma'am? I mean, why can't we include in that, ma'am?
No, just ask your question clearly. We are not talking about parallel lines here.
No, ma'am. Ma'am, if they ask us prove that triangle ABC is congruent to DEF means, ma'am, in this we are proving that AB is parallel to DE, no, ma'am. For first statement, AB is parallel to DE, no, ma'am.
Not AB parallel to DE.
Sorry, ma'am. AB is equal to DE.
You can take any, see, I think your question is this. Yeah, we are given AB is equal to AC. I'm sorry, AB is equal to DE, AC is equal to DF, and angle A is equal to angle D. I think your question is, why not AB equal to DE, BC equal to EF, and angle B equal to angle E, correct?
Yes, ma'am. That's my question.
Yeah, very well. If you, that also,
Ma'am,
yes.
but BC and EF comes under corresponding parts of congruent triangles, no, ma'am. Why, ma'am? Why can't we prove in statements itself, no?
BC and EF?
Ma'am, after proving that BC and EF comes under CPCT, no ma'am, corresponding parts of congruent triangles. Why can't we prove in that itself, ma'am? In we are proving that no ma'am, AB is equal to D. Why can't we prove there itself, ma'am?
No, you come ask one by one. Now AB is equal to DE. This information is given. What is your question? Why can't we?
Ma'am, instead of angle A and D, why can't we prove that BC is equal to EF, ma'am?
Why
BC
not
is equal to E.
Why not BC equal to EF is given, is it?
Ma'am, why can't we prove it in that triangle, in that congruence, ma'am?
No, we have shown that. No, we have shown that when you place triangle with this information, when you place one triangle over the other, BC coincides with EF is what we see. It
Yes,
does.
ma'am, but BC and EF comes under corresponding parts of congruent triangles by CPCT. Why it is coming there, ma'am?
No. You're going ahead because you know more about the chapter. You're going ahead. This is a demonstration. This is a demonstration to show that if with these three pairs of equalities, it is sufficient to show that the triangles are congruent.
Okay, ma'am.
No, you unlearn all that you have in your mind and you just take this. This one is just to prove that with these three pairs of equalities, we can show that the triangles are congruent to each other. Later, you are talking about the situations in the exercises where when we use SAS congruence criterion and show that the triangles are similar, yes, then we will write BC is equal to EF, CP, CTC because they are the corresponding parts of the congruent triangles. This is the proof for SAS congruence criterion itself. Why SAS congruence criterion works, how it works. So you're demonstrating, you're trying to show, or we are not actually demonstrating. So when you have these, the cutouts of the two triangles, you can perform it and see it yourself that with this information, the two triangles will be identical. So there is nothing to do. CPCT doesn't come here. In the exercise, so now this is proving SAS is a valid congruence criterion. When you apply this in a problem in the exercise, then yes, you will say that the triangles are congruent to each other. CPCTC, angle B is equal to angle E, angle C is equal to angle F, and BC is equal to EF. That comes later.
Okay, ma'am.
Yes, others? Children, are we there?
Yes, ma'am.
Do we
Yes, ma'am.
understand?
Yes, ma'am. Understood.
Yes, ma'am.
So just imagine you have two triangles in your hand. One triangle ABC, another triangle DEF. In these two triangles, you know that AB is equal to DE, AC is equal to DF, and angle A is equal to angle D. You have two such triangles with you. So what you're doing, you can place even D over. I have explained here for ABC being placed over DEF. You can do anything. Both amounts are the same thing. So you're trying to place this triangle ABC over this one. Since you know that angle A is equal to angle D, you're trying to place this triangle over this in such a way that A coincides with D. Is that fine?
Yes, ma'am.
Yes, ma'am.
Now you just adjust, you place A over D, and maybe you'll have to do a slight adjustment and see to that AB falls on DE. Adjust it and see to that AB falls on DE. But AB is equal to DE. So what you will observe is that this vertex B will fall on the vertex E because AB is equal to DE. AB is not longer. If AB was longer, then B will be outside E. Since AB is equal to DE, you will see that the vertex B falls on the vertex E. That is one part. Next, Angle A is equal to angle D. The opening is the same in both the cases. Angle A is equal to angle D. So what you will see on the other side is that this side AC will fall along. You don't have to adjust. You will see that it automatically falls along the side DF. You should perform this activity. To believe, you should perform this activity. So you will see that AC will fall along DF. And since AC is equal to DF, you will not see C outside EF. C will coincide with F. C will fall on F. So B falls on E, C falls on F. That means BC will fall on EF, which means BC coincides with EF, or BC falls on EF, or you can say BC is equal to EF. So BC coincides with EF. So what more do we need? Now all that means this triangle ABC, when you place it over DEF, it covers DEF exactly, not more, not less. It covers it exactly. They coincide. ABC and ABC coincides with DEF. That means they're identical. That means they're congruent. So this information is sufficient. So this is to validate SAS congruence criterion. This activity validates SAS congruence criterion. So if you have two triangles with such an information, they are congruent to each other. And once they are congruent, then you will say CPCTC angle B is equal to angle E, because they're the corresponding angles in the two congruent triangles. And angle C is equal to angle F, because again they're the corresponding angles in the two triangles. And BC is equal to EF. They're the corresponding sides in the two congruent triangles. That is not to be mentioned here. Any questions, children?
No doubts, ma'am.
No, ma'am.
My voice is clear, right?
Yes, ma'am.
Yes,
Clear.
ma'am.
Okay. So here we have a triangle. So we have to prove the statement. The angles opposite to two equal sides of a triangle are equal. So we have a triangle. Say these two sides are equal. We have a triangle ABC in which AB is equal to AC. All right. So when these two sides are equal, we need to prove that the angles opposite to them. The angle opposite to AB is angle C. The angle opposite to AC is angle B. So you need to prove that in a triangle when two sides are equal, AB is equal to AC. When two sides are equal, the angles opposite to them are also equal. That is, angle C is equal to angle B. Because angle C is opposite to this side. Angle B is opposite to this side. For this, we need to take up a construction. To prove this, we need to take up a construction. Let's draw AD. Let's draw AD. We are given only triangle ABC. With AB, you can see it here. We are given a triangle ABC with AB equal to AC. We need to prove that angle B is equal to C. Now this AD comes later. AD comes later. AD comes later. AD is a construction. AD is the bisector of angle A. We want to divide this triangle into two smaller triangles, and we can show that they are congruent to each other. And once they are congruent, their corresponding angles are equal and their corresponding sides are also equal. So when you have to prove angle B is equal to angle C, we divide this whole triangle into two smaller triangles with the help of AD, which is the bisector of angle A. Now, when you prove that this triangle is congruent to this triangle, this angle will be equal to this angle by CPCTC. We'll see how. So what is given? It's an isosceles triangle. It's an isosceles triangle. ABC with AB equal to AC. With AB equal to AC. Construction, draw AD, the bisector of angle A. Draw AD, the bisector of angle A. So if AD bisects angle A, that means angle 1 is equal to angle 2. Because if this angle is 80 degrees, it becomes 40-40. This angle is 80 degrees, it becomes 40-40. So angle 1 is equal to angle 2 because AD is the bisector. So now we have two triangles. We have two triangles. Take up the two triangles. See in triangle ABD, this is one triangle, and the other triangle ACD in these two triangles. All that you mentioned here should be about the first triangle, should be about this first triangle. And all that you mentioned here should be about the second triangle with an equal to sign in the middle. You must mention parts of the first triangle equal to the corresponding parts of the second triangle. So take up two triangles, write three pairs of equalities satisfying any one of the 5 congruence conditions. Now, so far we have come across only SAS. So this one is using SAS. So I said take up two triangles. What you write here should be about the first triangle. What you write here, that is the LHS on the LHS of the equality of the first triangle. RHS of the equality second triangle. You cannot write two things from the same triangle and say they are equal. You cannot write two angles from the same triangle and say they are equal. That is one information. No. One angle of the first triangle should be equal to the corresponding angle of the second triangle. You cannot write the details from the same triangle. From one triangle, you cannot write, two sides of the same triangle are equal. That is not a valid information. Okay, so you can see here of the first triangle. AB of the first triangle, side AB of the first triangle is equal to side AC of the second triangle given. Next, AD.
Ma'am, we can write A is the midpoint. Like that we can write.
What?
Ma'am, in that AB is equal to AC, ma'am.
Yeah.
We can write A as midpoint like that, ma'am.
A is the midpoint of?
Oh, sorry, ma'am. I didn't notice that. I thought that the BDC. I thought.
Okay. So AB, side AB of the first triangle is equal to side AC of the second triangle. Then AD, we'll write this information by, I should have put this one first. It's okay, I'm particular about the order. By mistake, okay, we'll write this one because we're going to use SA, so we'll write it according to that. So this is about one pair of equal sides. Then this one, angle 1 is equal to angle 2. That is BAD is equal to CAD. Angle 1 is equal to angle 2, correct? Angle 1 is equal to angle 2. That is what is angle BAD is equal to angle CAD. That is by construction. Then, so see here, angle 1 is of the first triangle. Angle 1 is of the first triangle. Angle 2 is of the second triangle. Angle 1 of the first triangle is equal to angle 2 of the second triangle. That's a valid information. This is of the first triangle. This one is of the second triangle. They're equal. One pair of equal angles. And then AD is a side which is common to both the triangles. AD is a side of the first triangle. AD is also a side of the second triangle. So AD is equal to AD common side. So this makes S, children, I should have written this one first, okay? Meaning this is the first point. The order is not important. I am saying we follow an order. No, excuse me, Shreyas, I'll just finish, okay? You can get back with your questions once I finish the proof. So the order
Okay, ma'am.
is not important, but we'll follow an order. We'll write the equalities in the order of the congruence rule. Like actually, before you prove, you would have decided which rule you're going to use based on the information given. Even before you write all this, you should have decided which rule you're going to use, because based on this rule only you're going to you're going to list the equalities. So once when you have a meaning with the details you have with you, you will first decide the rule. So you know you have one pair of equal sides, and then this one is common, and you also understand that angle 1 is the included angle, is the angle included between these two sides. In the first triangle, you can see AB, AD, these two sides include angle A. And the second triangle, you can see that this side AD and this side AC, they are the arms of angle 2. They are the arms of angle 2. That means angle 2 is included by AD and AC. Angle 1 is included by the sides AD and AB. So with the information we have with us, we decide that these two triangles are congruent by SAS rule, by SAS congruence criterion. So we'll write the equalities in that order. So we'll write this one first, AB is equal to AC. You can also write AD is equal to AD first, because that is also an equality on the sides. You can write AD is equal to AD also first. You can write this one also first. Any one of these two first. S. Then A. So we'll write angle 1 is equal to angle 2. This one is the second point. Second equality, angle 1 is equal to angle 2. And then the third equality, whichever you have not written. If you have not written AB is equal to AC, that will be the third one. Or if you have not written AD is equal to AD, that will be the third one. So that makes SAS. It's not SSA, it's SAS. So say I write AB is equal to AC. Then angle 1 is equal to angle 2. That is A. The first one, AB is equal to AC, is S. Then angle 1 is equal to angle 2, A. Then AD is equal to AD is again S. So SAS rule the two triangles are congruent. So now that the two triangles are congruent, the order in which you name the triangles is very important. The order in which you name the triangles is very important. So see, how did we go? We wrote about this side BA, then this angle 1, and then AD. See here, just follow some path. So it's like we mentioned about the side BA. We mentioned about the side BA. Then we mentioned about angle 1, SA, correct? This is SA, this angle. And we have also mentioned about the side AD. You can see the information we have listed here. AB, AD, and angle 1. And angle 1. Identify these in this figure here. So we have mentioned about the side AB. We have mentioned about the side AD. And we have mentioned about angle 1. So see the order like this: BAD, BAD, triangle BAD, triangle BAD. Now go in the same direction. Go in the same direction. In the other triangle, we have mentioned about the side CA, then angle 2, and the side AD. CA, side CA, angle 2, and the side AD. So that makes it CAD. CAD. Triangle BAD congruent to triangle CAD. If you write triangle ABD, supposing you write ABD, if you write ABD, then you must say ABD is congruent to. If you say ABD, then what should you say here? The order in which we name the triangles is very important. If you change the order here, if you write this as ABD, then you must write this one as
ACD, ma'am.
ACD. You must write this as ACD. ACD. If I write it as DBA, then if I write it as DBA, I should say
Ma'am,
congruent.
CDA.
Ma'am.
Yeah, if I write DBA, DBA, then I must write DCA,
DCA, ma'am.
DCA, DCA. If I say ADB,
ADC, ma'am.
ADB, if I say ADB, ADB is congruent to,
ADC, ma'am.
you should
ADC, ma'am.
take any, don't see everything. I'm just using this and renaming both the triangles. So if I say A, D and B, then I must say A, D and C, ADC, A, D. Because only if you write this order correctly, you can get the other pair, you can identify the other pairs of equalities. Because now that the triangles are congruent, it means they're identical. So the order in which you name the triangles is very important, because only that order will tell you the other pairs of equalities. The other pairs of equal angles or equal sides, you can identify correctly only if you name the triangles in the correct order. So whichever ways. So I have here written ABD, ACD. This is not the only way of writing SAS criteria. So this is not the only way of writing. This is not the only way of writing. You can write any one. You can write DBA congruent to DCA, ABD congruent to ADC. Everything amounts to the same. You're matching the vertices in any of these ways of writing. So now if you go with this, it means vertex A goes with vertex A. That means the angle 1 is equal to angle 2. Then vertex B goes with vertex C. That means angle B and C, right? So that means angle B of the first triangle is equal to angle C of the second triangle. That's what we had to prove. That's what we had to prove. Angle B is equal to angle C, CPCTC. Then it also means that angle D is equal to angle D. See, which are the angles of the triangles? This 1, 2, 3. And here this one, 1, 2, 3. So according to this order, we understand that angle 1 is equal to angle 2. Then angle B is equal to angle C. Here, B is equal to C. B is equal to C. And then D is equal to D. D is equal to D, meaning D of the first triangle is equal to D of the second triangle. This is D of the first triangle. Don't wonder, don't think D is only one angle. D represents two angles in the two different triangles. In the first triangle, this is D. In the second triangle, this is D. Children, am I audible?
Yes, ma'am.
Yes, ma'am. Audible.
Yes, ma'am.
Okay. And it also means side AB is equal to side AC. That we already know. AB is equal to AC, we already know. Okay. Then it means side BD is equal to the side CD. Side BD. Oh, BD is equal to CD. New information. The triangles are congruent. So BD is equal to CD. You can see from the order here. BD is equal to CD. Sides.
Yes, ma'am.
Side
D as
BD is.
midpoint.
Yeah. So that means if BD is equal to CD, that means D is the midpoint of BC. Then also AD is equal to AD. Yeah, that also we know, no? AD is a common side, so AD is equal to AD. So when you name the triangles in the correct order, you can identify the corresponding angles that are equal and the corresponding sides that are equal. Here, when we say corresponding angles, it is not that not the corresponding angles which we use in with reference to transversal and parallel lines. It's not that. It's not that corresponding angles. Here, corresponding means one angle relates to the other angle. One angle of the first triangle is equal to one angle of the second triangle. So another way of naming the triangles, another way of naming the triangles in the correct order is, now we have these two pairs of equalities. Now look at them. Which are the now in AB and AD, which is that vertex which is common in AB and AD? AB and AD, which is the vertex which is common? A.
A, ma'am.
A. So write AB as BA and AD as AD itself. In the rough column, just write these equalities in a different way. What I'm saying is, A is common. A is common. Let the first one end with A. Let the second one start with A. That common vertex. Let the first one end with A. Let the second one start with A. Here, which is common? What's common here?
A, ma'am.
A. So let the first one end with A. So CA. AC, CA, both are the same. Side AC, side AC, side CA, both are the same. So because A is common, let's write AC as CA. And here AD. Let the first one end with A. Let the second one start with A. Start with A.
EA, ma'am.
Let the first one end with the common vertex A. Let the second one start with A. Now see the order. Triangle BAAD. See a BAD. CAD. This is repeated, no? So leave it. Triangle BAD is congruent to triangle CAD. You can always use this method. See that 7 kind of here. BAD congruent to CAD. Understand or no, children?
Yes, ma'am.
Yes.
Yes, ma'am.
Triangle BAD, because here BAD. We are omitting this one. This is repeated. We already have A here. Leave that. CAD, like a 7. So BAD is congruent to triangle CAD. Now, if I say ADB, if I say ADB is congruent to children, ADB is congruent to
ADC, ma'am.
ADC.
ADC, ma'am.
ADB will be congruent to ADC. ADC. So now that the triangles are congruent, their corresponding angles are equal. So we have only one pair of, we know only one pair of equal angles by construction. Angle 1 is equal to angle 2. Which are the others? So angle 1 is equal to angle 2, so angle A is equal to angle A.
Angle B is equal to angle C, ma'am.
Yeah, the others are, now that the triangles are, see, now we only know angle 1 is equal to angle 2 by construction. We don't know about the other angles. Once we prove that the triangles are congruent, they're unknown. We don't know certain equalities, right? Now they are also equal because the triangles are identical. The remaining pairs of corresponding sides and angles are also equal. So that corresponding sides or angles can be identified only when you name the triangles in the correct order. So it means angle D is equal to angle D. Angle D of the first triangle is equal to angle D of the second triangle. This is angle D of the first triangle. This is equal to angle D of the second triangle. Then angle B of the first triangle is equal to angle C of the second triangle. This is angle B of the first triangle equal to angle C of the second triangle. This is what we had to prove. Angle B is equal to angle C. So write only that. Don't write everything. I was just showing you what other equalities we get once the triangles are congruent. But you don't have to write everything. So since we have to prove that angle B is equal to angle C, just write that angle B is equal to angle C, CPCT, or you can write CPCT-C also. CPCT-C also. Corresponding parts of congruent triangles are congruent, are equal. Congruent means equal. corresponding parts of congruent triangles are congruent. So just write B is equal to C, CP, CTC. So we proved when AB is equal to AC, when two sides are equal in a triangle, we proved that when two sides are equal, when AB is equal to AC, when two sides are equal, AB is equal to AC, angle B is equal to angle C. The angles opposite to them are also equal. We proved using SAS congruence criteria. See, when I write on the board, I always write it in that order. Here, while typing, I've just gone wrong. So always write in that order which the congruence rule says. SAS. So one pair of equal sides. Excuse me, Shreyas, 1 minute. One pair of equal angles, and then another pair of equal sides. So SAS. Got the children?
Yes, ma'am.
Yes, Shreyas, what's your question?
Ma'am, you said no, ma'am. This AB is equal to AC. We have to write in that order, no, ma'am. Yes, yes.
Yeah.
Ma'am, is it compulsory to like that write that, ma'am? Because we don't know what congruency is gonna come in the triangle, no, ma'am.
No, let me ask somebody else because I did mention that. Who can answer his question? Shreyas' question is, how do we know which order we should write the equalities? Because only after writing we know the congruence rule. Can anyone answer his question? I said we have to write the equalities in the order according to the rule which you're using, which you're going to use. But Shreyas' question is, only if we write, we will know which rule is going to happen. I mentioned that. What did I say? Is my question clear?
Yes, ma'am.
Yeah. Shreya, that was your doubt, right?
Yes, ma'am. I thought you're asking audible. Am I audible?
Okay, okay. Others. Shreya's question, Shreya's understands. What about the others?
Yes, ma'am.
Where are the others? Use the emoji. Raise your hand, children. Okay. All of you are there, but okay. Is the question understood by all? Shreyas, I said, yeah, I said write the equalities in the order in accordance with the congruence rule. But Shreyas' question is, only if I write, I'll know which rule I'm going to use. How can I write it?
I too had the same doubt, ma'am.
Oh, very good. So thank you, Shreyas, for asking that question. But I must say I mentioned it. But maybe I was too fast and you couldn't catch that. If you see the recording, you will see that I did mention that. So I said, when you have
Okay.
to, yeah. Okay. I said, when you have to prove that two triangles are congruent, look at the information given to you. Based on the information, decide which congruence rule you have to use. You have 5. You cannot always use ASA. Only if you are given 2 pairs of equal angles and that included sides equal in the 2 triangles, you can use ASA. But if you have information only regarding the sides, you can use only SSS. So depending on the information given, decide the rule first. Only 3 equalities we have to write. Children, 1 second. I've got a call. I need to attend that. Just a second, children.
Okay, ma'am.
Yes, children. So I was telling, when we are given 2 triangles and asked to prove that they are congruent, of course, we will be given some minimum information. So we need to look through the information, understand the equalities given to us, and decide the congruence rule which has to be used to show that they are congruent. Because otherwise you will just be writing some equalities. You have to look at the information and decide beforehand. Even before you start writing, you should decide the congruence rule. That's how it works. This is not numerical. It's not that you have an equation, and when you have an equation, of course, you have to work to know what is going to happen. You cannot decide the fifth step even before you start working. When it is numerical, the approach is different. When it's numerical, maybe in the case of equations, you read the information, you construct the equation, and then you have to start solving it. As you solve, only when you do the second step, you know what the third step is going to be. When you complete the third, you know what the fourth is going to be. With the equation with you, you cannot decide the fourth step. That is the case of numerical situations. This is theoretical. Here you can see, like when you have to write a theory paper, you know the content, you have the content already in your mind. Now don't tell me essay, you will not have the content. Leave that. If you have to write an essay on a particular topic, yes, you're going to think and then write. But in general, when it is theory, you have the content in your mind. So you know what you're going to write. In the same way here, you should look at the information and decide the rule which you have to use to show that the triangles are congruent. And based on that, you should write the equalities in that order. So here, after the construction, we have to analyze what do we have in this triangle. This side is equal to this side. So that is, we have one pair of equal sides. Then we have this angle equal to this angle. So we have one pair of equal angles. We have one pair of equal angles. And then this is a common side. So we have information. We have two pairs of equal sides. And this angle happens to be the included angle in both the triangles. So we have information regarding two pairs of equal sides and one pair of equal angles, where the angles are included angles in the two triangles. So I know it is going to be SAS. I know that the two triangles are congruent by the SAS congruence criterion. So I'll write that one pair of equal sides first, then one pair of equal angles, and then the other pair of equal sides. So SAS. If you still didn't get me, children, please tell me. I'll just I'll try to make myself.
No, ma'am, understood.
All of us.
Yes, ma'am, understood.
Kanishka, you said even you had the same question. Understood, Kanishka? I can't hear her. What about the others? Please acknowledge.
Yes, ma'am,
Understood, ma'am. Understood.
Only Hitesh and Shreyas have been acknowledging. Others, please acknowledge. All right.
Understood, ma'am.
Okay, Sangamitra. No, I have no choice. I have to just laugh it out and go to the next one. Okay, I cannot wait beyond this. I have to assume, I'm forced to assume that all of us have understood. Okay, this is what it is. Always, we have to decide just 3 equalities. Not a big deal. It's not 15 equalities that it's difficult to decide the congruence rule. Simply 3. You just have to put them in the order. Does it follow the SAS order, RHS order, AAS or ASA or SSS? Very simple. Just 3 equalities. You should place them correctly and understand the rule. and write it in the same order. Okay. So this is the angle side angle convergence criterion. So this one is in two triangles. If two pairs of angles are equal and the sides included by these angles are also equal, the sides included by these angles are also equal, then the two triangles are congruent by the ASA congruence criterion. This is the proof for the criterion itself. We are not proving that two triangles are. See here in the earlier one also, you should not write ABC congruent to DF by SAS rule. This one is the proof for SAS itself. We are trying to say that SAS is a valid congruence criterion. You should not write ABC congruent to DF by SAS criterion. Children, I'll just get back. Yeah, children, what was I telling you? Yeah. So according to this ASA congruence criterion, when in two triangles, we have two pairs of equal angles and the sides included by these angles, the sides included by these angles are also equal, then the triangles are congruent by the ASA congruence criterion. This is the proof for the criterion. So nowhere we will write by ASA. We are proving this using the already proved SAS congruence criterion. See here, we've already proved the SAS congruence criterion. So we are going to validate. We are going to validate ASA congruence criterion using SAS. You cannot write triangle ABC congruent to DF by ASA. This is the proof for ASA. This is the proof for ASA congruence criterion. So nowhere you will see the triangles are congruent by ASA. This is the proof only for that. So we are going to prove or we are going to validate ASA congruence criterion using the already validated SAS congruence criterion. Using the already validated SAS congruence criterion. So you will see SAS. If at all you see, you will see SAS. You will not see ASA anywhere. This is the proof only for ASA. Then how can you say by ASA they are congruent? Is that part clear, children?
Yes, ma'am.
Yes, ma'am.
Don't make me feel bad. Huh? Please acknowledge. You can say no, you can say yes. I'm not forcing you to say yes, right?
Ma'am, no, ma'am. Understood, ma'am.
Understood,
Okay.
ma'am.
All right. So see the statement. Two triangles are congruent if two angles and the included side of one triangle. So see here, two angles. So here in triangle ABC, the two angles are angle B and angle C. Angle B and angle C include the side BC. See here, angle B, angle C, side BC, included side. Angle B, angle C, side BC. So angle B and C include the side BC. Similarly, in the other triangle, angle E and angle F include the side EF. For angle E and angle F, ED is not the included side. The angle E, angle F, EF is the included side. Do you understand the included side?
Yes, ma'am.
Yes, ma'am.
Included side for angle,
Yes, ma'am.
which is the included side for angle A and angle B? For angle A and angle B, which is the included side?
AB, ma'am.
BA, ma'am.
BA or AB? For angle F and angle D? For F and D, angle F and angle D?
DF or
DF,
FD, ma'am.
ma'am.
DF.
DF or FD is the included side. Okay. Somebody's mic is enabled. Please disable your mic. All right. So here we have two triangles with such an information. What that two angles, the two angles and the included side of one triangle equal to the corresponding two angles. So this angle B is equal to angle E and this angle C is equal to angle F, equal to the corresponding two angles of the other triangle, and the included sides are also equal. The included side, EF is the included side in the second triangle. The included side in the first triangle is BC. BC is equal to EF. Given this, we need to show that the triangles are congruent to each other. That is, if two angles and the included side of one triangle are equal to the corresponding two angles and the included side of the other triangle, then the triangles are congruent to each other, is what we have to prove. So we're going to prove or we're going to validate ASA congruence criterion using SAS. So we are going to show that these two triangles are congruent by the SAS congruence criterion. We're going to show that if these two triangles exhibit this information, exhibit which information? Angle B is equal to angle E, angle C is equal to angle F, BC is equal to EF. This one, angle B is equal to angle E, angle C is equal to angle F, and BC is equal to EF. If in two triangles, we have such an information, then we are going to show that they are congruent. So that means ASA is a valid congruence criterion because we have information regarding two angles on the included side. Okay, so now to prove this, we'll have three cases. Now see, we have to show that the triangles are congruent using SAS only because we know only that. We know only that. We have performed an activity and understood that SAS is a valid congruence criterion. So what we do is we take up the two triangles. The first case being now to use SAS. See, we know this angle is equal to this angle. We know that this side is equal to this side. So we have like A and S. We have like A and S. What's my pointer? This is angle. This is angle. This angle equal to this angle we have. And this side is equal to this side. Now, which are the arms of this angle? This one is one arm. And this is the other arm. This is the other arm. So again, for this angle, this is one arm. And this is the other arm. This is the other arm. This is the other arm. We know that this angle is equal to this angle and one of its arms, this arm is equal to one of the arms of the other angle. So we don't know if this arm is equal to this arm. Only if we have this arm equal to this arm, then we can say SAS. We can say SAS, side, angle, side, two sides included angle. To use SAS congruence criterion and show that the triangles are congruent, we need to know like how AB and DE behave. Is AB less than DE? Is AB equal to DE? Or is AB greater than DE? I'll come again. For this, we know that this angle is equal to this angle. Now, these are the arms of angle B. These are the arms of angle E. These are the arms of angle E. We know that this arm of angle B is equal to this arm of angle E. If we know that this arm of angle B is equal to this arm of angle E, then it will make SAS because two sides included angle equal. Two sides included angle equal. So it's all dependent on AB and DE. If AB is equal to DE, that is the first case. If AB is equal to DE, that's the first case. If AB is equal to DE, then what happens in the two triangles? In the first triangle, the side AB is equal to the side DE in the second triangle. Okay, that is by assumption. We have supposed that, we have assumed that AB is equal to DE. So we're going to take all the three cases. We don't know if AB is equal to DE. We're going to take all the three cases. So in the first case, if AB is equal to DE, then if AB is equal to DE, then in the two triangles, AB of the first triangle is equal to DE of the second triangle. Then see here, angle B of the first triangle is equal to angle E of the second triangle. Given this first one, we have assumed. The second one is given. Then BC of the first triangle is equal to EF of the second triangle given. one side or angle of the first triangle should be known to be equal to the side or angle of the other triangle. So you can see that these three are parts of the first triangle ABC, and these three are parts of the second triangle DEF. AB is equal to DE is assumption. Angle B is equal to angle E given. BC is equal to EF given. So this makes SAS. Two pairs of equal sides and the included angles. One pair of included angles equal. How do you know that they are included angles? How do we know that they are included angles? So see here, angle B. Which are the arms of angle B? These are, see here, this one, AB and BC will be the arms of angle B. That's why angle B is included angle. DE and EF will be the arms of angle E. That means they're included angles. If we say that angle B is the included angle, that means AB and BC will be the arms of angle B. If AB and BC are the arms of angle B, that means B is the included angle. If DE and EF are the arms of angle E, that means E is the angle included by these two sides. You can check that here. Where is AB? This is AB. This is BC. This is the included angle. This is DE. This is EF. Include angle. So if we assume AB is equal to DE, then the two triangles are congruent by the SAS congruence criterion. So they're congruent. But what if AB is not equal to DE? What if AB is not equal to DE? If A, Shreyas, I think I'll finish and then you can just note down your question. You can ask me later.
Okay, ma'am.
Yeah. Case 2 is when AB, see, we have all the three cases. Here AB is greater than ED or DE. Here AB is less than DE or ED. So we know that SAS is a valid congruence criterion. So we have to, it's like as if now we only have that rule. We have to prove that the congruence, we have to prove that the triangles are congruent using this rule SAS. It's like that. So we are trying to find information. We're trying to find information that satisfies SAS rule. So now, again, we have angle B is equal to angle E, we know. Angle, BC is equal to EF, we know. Now we are concerned about AB and DE. If AB is not equal to DE, then maybe AB is less. So if AB is 4 centimeters, maybe DE is 5 centimeters. DE is 5 centimeters. AB is less than ED. AB is less than ED. That means if AB is 4 centimeters, then ED or DE is 5 centimeters. So then what we'll do, we'll take a point G on DE such that we'll take a point G on DE such that G is equal to 4 centimeters. AB is less, D is more than AB. So say D is 5 centimeters and say AB is 4 centimeters. We'll take a point G on DE such that G is equal to 4 centimeters. Now they're equal, no? Now AB is equal to GE. AB is less than DE. DE is the side of the triangle. D is only the side of the triangle. D is more, it's 5 centimeters. So what we'll do on DE, we'll take a point G. We'll take a point G such that G is equal to 4 centimeters. So now AB is equal to GE. Now AB is equal to GE. Now we'll join, we don't have a triangle, so we'll join FG. We'll join FG. We'll join FG. So see, now this angle is smaller. Angle GFE is smaller than DFE. So what is this case? AD is, in the first case, AB is equal to DE. Amount here. AB is equal to DE. AB is equal to DE. So easily the triangles are congruent by SAS rule. What if AB and DE are not equal? What if AB is less, 4 centimeters? What if DE is more, 5 centimeters? So then we'll take a point G on D. D is longer, no? So you can take a point G on D such that GE is equal to 4 centimeters. That is, GE is equal to AB. Then join FG. Join FG. Now take up the two triangles ABC and GEF. AB of the first triangle is equal to GE of the second triangle. By supposition, meaning we have assumed that. We have taken it like that. We have taken a point G such that GE is equal to AB. Angle B is equal to angle E known, given to us. BC is equal to EF, also known, given to us. So now it is two sides included angle. Two sides include, I told you, if the arms of the angle are the sides which we have mentioned, then they are the included sides. See, now you can check here. For angle B, this is the included angle. That means AB and BC are its arms. So see here, angle B, AB and BC are its arms. And we have mentioned about AB and BC only. We have mentioned about the arms of angle B. So that means two sides include angle. Angle E is included angle. Because we have mentioned about GE, we have mentioned about GE and EF. See here, GE and EF. GE and EF. So GE, EF include this angle. So this goes with SAS by SAS congruence criterion. The two triangles are congruent to each other. If now that they are congruent, their corresponding angles and corresponding sides must be equal. Now I've told you how to name the triangles. Use that method and name the triangles in the correct order. Take up AB, BC, AB, BC, ABC, AB, BC, ABC, GE, EF, GEF, GE, EF, GEF. So ABC is congruent to GEF by SAS congruence criterion. Now that the triangles are congruent to each other, their corresponding angles must be equal. So that means angle, we are concerned about this angle and this angle. We are concerned about these two angles. Because we know that they are equal. We know it's given that angle C is equal to angle F. Now let's see what happens out of this congruency. Angle ABC is equal to angle GEF. That means angle C, that is angle, what do you call this angle? Angle ACB. Okay, this is angle ACB is equal to angle F. Angle F and GEF. Angle F and GEF is only this one. This is only F and GEF. See here, you should be careful when you look at the vertices. Angle C and angle F. See the third vertex, angle C, the third vertex, angle F. This is angle F because the triangle is GEF. In GEF, this is only F. Not this fully. This is not F. This is not F. In triangle GEF, this is F. In triangle ABC, this is C. So you can see here the third letter C is equal to F. That means angle ACB is equal to angle GFE. ACB is equal to GFE, CP, CTC. But ACB, if we are given that ACB, is equal to DFE. We are given that ACB is equal to DFE here. But we are given that ACB is equal to DFE. So ACB is equal to GFE, ACB is equal to DFE. That means from these two, GFE is equal to DFE. GFE is equal to DFE. GFE, DFE, how can they be equal? GFE is this one. DFE is this one. This is DFE. DFE, DFE. DFE is this one extra, little extra. This is DFE. This is GFE. And they have to be equal. They can be equal only when the points D and G and D coincide. How can these two angles be equal? We've got that result that they are equal. We have got the result that they are equal. Because this result we get by CP/CTC. If this is true, if this supposition is true, then that means these two angles are equal by CP/CTC. This one is given. By comparing these two results, we have GFE is equal to DFE. GFE, see, GFE, this one, this angle, GFE, equal to DFE. So that is possible. GFE is equal to DFE. They can be equal only when the point G coincides with D. If G and D are two different points, then this is not true. G should coincide with D. If G coincides with D, that means AB should be equal to DE. Because if G coincides with D, that means AB should be equal to DE. So AB must be equal to DE, because this situation is not possible, or the situation is possible only if G and D coincide. So if G coincides with D, that means AB is equal to DE. So AB is equal to DE. So AB is equal to DE. Angle B is equal to angle E, that is known to us. And BC is equal to EF is also known to us. So the two triangles ABC and DEF are congruent by the SAS congruence criterion. I'll finish the third case also. Exactly like the second case. The third case. Now here, supposing AB is greater. AB is greater meaning AB is 5 centimeters. And DE, this is the triangle DEF. And say DE is 4 centimeters. AB is greater than DE. So AB is 5, DE is 4. So then what we should do? We should take a point G on ED produced. Because you want 5 centimeters. AB is 5. So you want 5 centimeters. So you will take a point G on ED produced. You will produce the side ED and take a point G such that G is equal to 5 centimeters. G is equal to 5 centimeters. Then join. See, it's like this. This is the triangle DEF. This is the triangle DEF. So you produce this, and you take a point G here, such that this length GE is equal to this side AB. So now join this to get a triangle. Join this one. Join this. That's what you see here. Join GF. So this case where AB is greater than ED, we'll have to take AB is greater, ED is small. So we'll take a point G on ED produced so that GE is equal to AB and join FG. Now take up the two triangles ABC and GEF. ABC and GEF. So in these two triangles, we have just by our assumption AB is not assumption, we have taken a point G such that AB is equal to GE. Our assumption is AB is greater than ED. So AB of the first triangle is equal to GE of the second triangle. Then angle B, this is known to us. Angle B of the first triangle is equal to angle E of the second triangle. In triangle, see, when in triangle ABC, we know that in triangle ABC, we know angle B is equal to angle E in triangle DEF. That also means that it is the same thing, no, in triangle GEF. This angle doesn't change. This angle is the same in triangle DEF and in GEF. It's the same angle. So angle ABC, this angle B is equal to this angle E. That's given to us. And BC is equal to EF is also given to us. So like this, SAS congruence criterion, the two triangles are congruent to each other. And I told you AB, BC, ABC, GE, EF, GEF. They're congruent to each other by SAS rule. So CP/CTC, we have this angle C is equal to angle F. So angle C of ABC is equal to F of GFE triangle is equal to this F is equal to this F angle. See, F is here, F is here, F is here. So GFE, see here, angle C, the third letter C and F. The third letter C and F. Vertex C is equal to vertex F. That is angle C is equal to angle F. Angle C is this one in the small in triangle ABC. Angle F is this angle. Angle F is this angle in triangle GEF. In triangle GEF. So CP/CTC we have ACB. ACB is equal to GFE. But what is given to us? What is given to us? ABC is equal to, see, we are given that C is equal to F. We are given that C is equal to F. That is angle C is equal to, that is angle ACB is equal to DEF is given to, DFE is given to us. Angle ACB is equal to DFE is given to us. ACB is equal to DFE. ACB is equal to DFE is given to us. This we get by CP/CTC. The triangles are congruent. So CP/CTC, but this is already given to us. So when you look at these two results, we understand that GFE is equal to DFE. GFE is equal to DFE. GFE is equal to DFE. What is that? GFE is equal to DFE. GFE. GFE is this angle. Is equal to DFE. Is equal to DFE. How is this possible? How can these two angles be equal? This one looks larger than this one. But we've got the result that GFE is equal to DFE. GFE is equal to DFE. That means the point G coincides with D. G is not a different point. G coincides with D. If G coincides with D, that means AB is equal to AD. That is the line segment DE and GE, they are not different. The line segment DE and GE, they are not different. G should if G coincides with E, if G coincides with D, if G coincides with D, that means there's only one line segment DE. G coincides with D. So this means that AB is equal to DE. There is no other point like G. G and D are the same points. G coincides with D. That means AB, this is not true. AB greater than ED is not true. That means AB is equal to D, because even if we took a different point G, and assume that AB is equal to G, it's not working. G is the same as a point D. So AB is equal to D. AB is not greater than D. AB is equal to D. So now in the two triangles, ABC and DEF, we just proved that AB is equal to DE. Angle B is equal to angle E, we already know, it's given to us. And BC is equal to EF is also given to us. So side, angle, side. By SAS rule, the two triangles are congruent to each other. So this proves that in two triangles, when the two angles and the included sides are equal, when in two triangles, the two angles and included sides are equal, then the triangles are congruent to each other. So this is the proof for ASA congruence criterion. ASA, which is proved using SAS. It's like as if we only know this rule. We have to prove or we have to validate ASA congruence criterion using SAS. So to use SAS, we are making use of two things which are given to us. This angle and this side which are given to us, A and S. This angle equal, side equal given to us. So we are concerned about the side, how the sides AB and DE must behave. How the sides AB and DE must behave. In order to use SAS, here SA, this is A, this is S. A, S. So we have one pair of equal angles. We have one pair of equal sides. So the other pair of equals, the other pair of sides, we have to take up this and this only, because that only will make SAS. Two sides included angle. So we are concerned about the lengths of AB and DE. So the three cases arise. What will happen when AB is equal to DE? What happens when AB is less than ED? What happens when AB is greater than ED? We see that these two cases are not possible, because even when we assumed AB longer or AB shorter than ED, we saw that that new point G always coincided with D, proving that AB will always be equal to DE. Proving that AB is always equal to DE. So the triangles are congruent to each other by SAS congruence criterion. Yes, Shreyas, if you remember your questions, you can ask me now.
Yes, ma'am. I still remember, ma'am. Ma'am, echo.
Yeah, tell me.
Ma'am, there is an SSS angle, ma'am.
No, as of now, we don't know. That's because you're already introduced to the chapters. See, we are going in the, it's like you're finding new things. As you're going your path, you first discover SAS. So using SAS, you discover ASA. Now using these two, you go ahead and you're finding SSS. It's like that.
Ma'am, but my question is there is SSS congruency, no, ma'am? Not in this question, ma'am. In general, there is SSS congruency, no, ma'am?
Yeah, there is.
Ma'am, why not there is AAA angle congruency, ma'am?
Okay, so think of an equilateral triangle. Think of an equilateral triangle with side 5 centimeters. Let's call it ABC. Okay. Okay, we'll say this is an equilateral triangle ABC with side 5 centimeters. 5. Okay. Now think of another triangle PQR of side, say 8 centimeters. Okay. Are the two triangles identical? Or one is small, the other
No,
is...
ma'am. They
They're
are
not
not
identical.
identical.
That means they're not congruent, right?
Yes, ma'am.
Because they're not identical. If they're not identical, they're not congruent. One is small, the other is big. So they're not identical. They're not. If they're not identical, that means they're not congruent. But their angles are equal, no? Everywhere it's 60 degrees. Everywhere it's 60 degrees. Angles are equal. Everywhere angles are 60 degrees. Then why they're not congruent? So this says that AAA is not a valid congruence rule. Just because in two triangles the angles are equal, corresponding angles are equal, it doesn't mean that the triangles must be congruent to each other. So this can be one example where, or one example which says that AAA is not a valid congruence criterion. Because here we have two triangles ABC and PQ both equilateral. So that means in both the triangles, the angles are equal. AAA. Angle A is equal to angle P. Angle B is equal to angle Q, 60 degrees. Angle C is equal to angle R, 60 degrees. Corresponding angles are equal, but they are not congruent. One is small, the other is big. They're not congruent. They're not identical. So AAA is not a valid congruence criterion. Got that?
Yes, ma'am.
Okay, children, any other questions?
No
questions.
questions.
No, ma'am.
So with the help of an activity, we like first find SAS congruence criterion. Then we move on. We take up two triangles where we have information about two pairs of equal angles and one pair of included sides equal. So at this point, we only know the SAS congruence criterion. We don't know any others. So we are trying to validate this congruence criterion using SAS. You can't use SSS, RHS because you haven't found them. You're finding rules one after the other. At this point, when you're thinking about ASA, you only know SAS. So we are using SAS to validate ASA congruence criterion. So we already have one pair of equal angles, one pair of equal sides. To use SAS, when angle B is equal to angle A, you must have for angle B, these are the included sides. Let me clear the. For angle B, the arms are BA and BC. And for angle E, the arms are ED and EF. So we know that it's given to us that BC is equal to EF. And angle B is equal to angle E. So to use SAS, we need to check on AB and DE. So the three cases which you can think of is, will AB be equal to DE, or will AB be less than DE, or will AB be greater than DE? So when AB is equal to DE, directly the triangles are congruent by SAS rule. But when AB is less or AB is greater than DE, we take a point on ED or ED produced. We take a point G. And when we prove that the triangles are congruent, we see that this point G always coincides with D. The point G, the new point G coincides with D. That means G and D are not two different points. Both are the same. Which proves that, so if there is no different point like the G, and if G coincides with D, that proves that AB is always equal to DE. So AB is equal to DE. SA is the triangular congruent. Same thing here. All right, children, that's it for today's session. If you have any questions, please stay back, else you may leave the meeting. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you, children.